Hello students, today we are going to study valency. Now there are two definitions of valency. Valency is the combining capacity of an atom. Here the valency of an atom is the number of hydrogen atoms that will combine with one atom of that element. For example, if we take HCl, right? So HCl is hydrogen chloride. Hydrogen chloride has one atom of hydrogen and one atom of chlorine. So one atom of chlorine combines with one atom of hydrogen to form a molecule of hydrogen chloride, right? So we'll say that the valency of chlorine is 1, right? So we can also say here, like hydrogen combines with, like this, it is a single bond is formed. Okay, now when we talk about here water, so another example is water, that is H2O, right? So in this water you will see two atoms of hydrogen. See here, these are, let us say these are the two atoms of hydrogen. So two atoms of hydrogen are combining with one atom of oxygen. Okay, so this is one atom of oxygen, you can say. So then only what is formed is, let us color it, so we will come to know this is oxygen atom. Okay, right? So when it will form water molecule, one atom of oxygen, and there are two atoms of hydrogen. So this is water formed, right? So valency of oxygen is 2, right? So here in this manner we can find out the valency. Now let us take another example, that is ammonia. Ammonia is NH3. 3 atoms of hydrogen combine with one atom of nitrogen. Okay, so here we will say the valency of nitrogen is 3. Okay, so as many hydrogen atom combining with another atom, that will be the valency of that element. So here nitrogen is 3, oxygen is 2, and here chlorine is 1, right? Now if we talk about, say, methane, methane formula is CH4. So in the case of methane, 4 atoms of hydrogen combine with one atom of carbon to form a molecule of methane, we can say. So the valency of carbon is 4. Valency of carbon is 4. Okay, so this is how we can find out the valency. So what is this? The valency of an element is the number of hydrogen atom that will combine with other atom. Okay, so this is one definition. Now let us understand the second definition. But to understand the second definition, we have to understand why do atoms combine. So here atoms combine with one another, atoms combine with one another to attain the stable electronic configuration. Now what is electronic configuration? You know that electronic configuration is the arrangement of electrons in different shell. So to attain stable electronic configuration of the nearest inert gas, or you can call it as noble gas, right? Inert gas, that is, they have to attain 8 electrons in its valence shell. So you will see over here all these noble gases are having 8 electrons in the valence shell, outermost shell. See here. Okay, so now to follow, see, we have 2 rules. Now let us understand 2 rules, and if any atom is attaining any of these rules, octet or duplet is fulfilling, then it is said to be stable. So let us understand what is law of duplet. Law of duplet is when an atom has, see, for an atom to be stable, it must have 2 electrons. It must have 2 electrons in its first and outermost shell. First and outermost shell, right? For example, over here helium, okay, so here element helium, right? And let me tell you, only and only helium is the element in whole periodic table which satisfies duplet role. You will see this is the first shell and this is only the outermost shell, and helium has 2 electrons. So this is fulfilling law of duplet. Now what is law of octet? So law of octet is, for an atom to be stable, it must have 8 electrons. It must have 8 electrons in its outermost shell. All the other noble gases other than helium, okay, all the noble gases or inert gases other than helium, you will see all of them are having 8 electrons. So these are only the 6 elements in the periodic table who are stable, okay. So these are only stable whose octet and duplet are complete, okay. So helium's duplet is complete and neon, argon, krypton, xenon octet is complete. So these elements do not combine with any other element. See, we will say that noble gases rarely form compounds as they have most stable electronic configuration, that is complete octet and duplet. So they have no reason to react with other elements. All other elements attempt to gain, lose or share electrons to achieve this noble gas electronic configuration. And that is what our definition of, now the second definition of valency is. Now let us see what is the second definition of valency. See, valency can also be defined as the number of electrons lost, gained or shared during a chemical reaction. See, other than the 6 elements, rest all the elements in the periodic table are not stable. Now to become stable, they have to either lose electron or gain electron or share electron, right? So here, now to understand this, we have to understand all this, right? So what are valence electrons? The electrons present in the outermost shell of an atom are known as valence electrons, and these valence electrons play an important role in chemical reaction. Right? They only take part in the reaction. Okay, valence electrons take part in the reaction. Now let us understand this table. Now after understanding this table, it will be very clear how these atoms lose, share and electrons, okay, to become stable. Now sodium's electronic configuration, we see here 11 is the atomic number and this is the mass number. So electronic number always protons, so the protons are 11, so electrons are also 11, and distribution of electrons is the electronic configuration. So now if you want to distribute 11 electrons in these different shells KLMN, the distribution will be 2, 8, 1, right? So here let us write the electronic configuration of all the elements. 12 is 282, 13 is 283, 14 is 284, 15 is 285, that is phosphorus, sulfur is 286 and chlorine is 287 and argon is 288. Now as I told you here, what are valence electrons? You will see here valence electrons. So what are valence electrons? Electrons present in the outermost shell. So these are the electrons which are present in the outermost shell. So here the valence electron of sodium is 1, magnesium is 2, aluminum is 3, silicon 4, phosphorus 5, sulfur 6, chlorine 7 and argon 8. Now in this case sodium, what is the valency of sodium? Now see, valence electrons will take part in the reaction 1. Now its octet is not complete. So to complete octet, this has to lose 1 electron. See, outermost shell, an atom must have 8 electrons. So here it is not having 8 electrons. So to complete its octet, it will lose 1 electron. And another thing, if you look at, see, these are metals, sodium, magnesium and aluminum. 1, 2, 3, if electrons are there, it is very difficult to gain 7 electrons. So it is easy to lose 1 electron. So when it loses 1 electron, the valency becomes 1. Now to understand that, let us understand first this thing. Here let us take an example of say sodium. Okay, sodium is Na. Sodium, see, atoms are always electrically neutral. Sodium's electronic configuration is 281. How many protons? Protons are 11 and electrons are also 11. See, as many positive charge, those many negative charge. So an atom is electrically neutral, right? Now, in this case, what is happening? To become stable, it has to lose electron. So let us say sodium is losing one electron and it becomes Na plus. Now, why is it becoming positive charge? Why it is becoming a cation or a positive ion? So when it will lose electron, what will happen? The electronic configuration will become 2,8. Protons are 11 only, but one electron is lost, so electrons are 10. So one proton, one positive charge is more, one proton is more, so Na plus, right? And similarly, let us see the opposite side. What is happening? Sodium loses, so some other element will be gaining, the one who is in need. So let us take the example of chlorine. Okay, chlorine, here you will see chlorine's electronic configuration is 287. So 287 is the electronic configuration of chlorine. Chlorine has 17 protons and 17 electrons. Now to become stable, this is in need of one electron only. So it is difficult to lose 7 electron. It is easy to gain 1 electron to complete octet, or you can say to become stable. So to become stable, it will gain 1 electron and it becomes Cl minus chloride ion. Now when it becomes chloride ion, 288 is the electronic configuration. So it is becoming, it is stable. Protons are 17 and electrons are 18. Now you see, electrons are 18, one negative charge is more, see, and now it is minus. That is why 1 minus. So this 1 minus is the charge of this chloride ion, and now we can say it is the valency. So what is the valency of chlorine? Is also here valency of chlorine is 1, right? So why the valency of chlorine is 1? Because it is just gaining 1 electron. So let us take one more example to understand this better. Now let us take another example, magnesium. Magnesium electronic configuration is how much? 282. Atomic number is 12, so electronic configuration is 282. Distribution of electron is like this. Now this has 12 protons and 12 electrons. Always an atom is electrically neutral. As many positive charge, those many negative charge. So we say an atom is electrically neutral. Ions are never electrically neutral. They are charged particles. These are called ions. Okay, they are charged particles, right? So they will never have equal number of proton and electron. If number of protons are more, they are positive charge. Number of electrons are more, then they are negative charge. So I'll say here more electrons, then negative charge. Okay, then negative charge an atom will have. And if an atom has more protons, okay, then it will have always positive charge. Okay, so an atom will have positive charge. And now in this case, you see, magnesium has to lose 2 electron to complete octet. So it loses 2 electron, it becomes Mg2 plus. Now this 2 electrons, suppose imagine oxygen is in need of this 2 electron. Okay, so oxygen's electronic configuration is here not given, but oxygen's atomic number is 8 and electronic configuration is 6. So it needs 2 electrons. So suppose magnesium is losing 2 electrons and those 2 electrons oxygen is gaining to complete its octet. So it gains 2 electrons to then becomes oxide. So here magnesium has to lose 2 electrons, then its octet is completing 2,8. Okay, and now protons are 12 but electrons are 10. As I told you, if more numbers of protons are there, then it is positive charge, Mg2 plus. So the valency of magnesium is M2, right? Similarly, these 2 electrons, this non-metal is in need of 2 electrons. Why? Because the outermost shell 6 electrons. So it is in need of 2 electrons to complete octet. Now difficult to lose 6 electrons, easy to gain 2 electrons. So it will gain 2 electrons and its octet is complete. So here protons were 8, electrons were 8, but here protons are 8 and electrons are now become 10. So 2 minus, more electrons, so negative charge, right? So now let us understand how we can find out. See, any atom, if in the outermost shell has 1, 2 and 3 valence electron, they will lose these electrons. Okay, they will lose these electrons and their valency will be 1, 2 and 3, right? And these are all, what is the nature? They are all metallic in nature. Okay, so all of them are metallic in nature, these three, right? Now we'll say metals, okay, lose electrons to form cations, to form cations. Cations means they are positively charged ions, positively charged ions are known as cations, right? Now let us see this. Here silicon, phosphorus, sulfur, chlorine, now they have their 4, 5, 6, 7 valence electron. We saw over here 6 and 7 valence electrons, you see. So 6 oxygen has and it has 7. So if the valence electron is 4, they have to either gain 4 or they have to share 4 to complete octet. So just you can do 8 minus 4, so valency is here 4. Now here valence electrons are 5, so it has to gain 3 electrons, so valency is 3. To complete octet it has to gain, so or you can do 8 minus 5 is 3. Now here you have seen 6 valence electron, 2 examples. Sulfur is also having 6 valence electron, oxygen is 6, so it is in need of 2 electron to complete octet, so 8 minus 6 is 2. Okay, so now all the elements whose valence electrons are 4, 5, 6, 7, their valency will be 4, 3, 2, 1. They are non-metallic in nature. Okay, non-metallic, right? And always non-metals have, non-metals, they gain electron to form an ion, and these anions are negatively charged particles. Negatively charged ions are known as anions, right? Now in the case of argon, as I told you, all these 6 are stable. They have 8 already, octet is complete, so the valency is 0. 8 minus 8 is 0, and it is inert gas. Inert means least reactive. Okay, so how do we find valency? So here valency, what is the definition? The number of electrons lost, here the number of electrons lost, gained over here, how many electrons are gained, or sometimes we'll see in covalent further how they share the electrons during a chemical reaction. So when the chemical reaction here, like this is the chemical reaction, so we'll say in this case we can also say like this. See, when sodium is losing 1 electron and chlorine gains 1 electron, what is the compound formed is sodium chloride. Okay, in sodium chloride the ions are Na plus and Cl minus, oppositely charged ions are formed and they are bonded by electrostatic force of attraction, and then we balance the reaction. So during the course of reaction, one is losing, another is gaining to form a stable compound. That is how we know the valency. Okay, so thank you students.